Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Multimeter by Dubious and Mobius. And here are the rules. Sudoku, place the digits 1 through 9 once each in every row, column, we can get a column here, and 3 by 3 box. Quads, digits in circles must appear in one of the 4 adjacent cells. So for example, around this quad, there's a 2 and a 9 in the circle. So there must be a 2 in one of the 4 cells surrounding it, and a 9 in one of the 4 cells surrounding it. Similarly, in this quad, there's only a 6, so we just know that there's a 6 in one of the 4 cells surrounding this quad circle. And same with this circle, having a 5, we know there's a 5 in one of the 4 cells surrounding this quad circle. And that's how quads work. Now this is appendix lines, which is a new rule set for me. These are like an index line, but with repeating positions. Along a line, if a digit D appears in the pth position, starting at the large diamond, so starting at the large diamond in each of these lines, then the digit P must appear in the dth position along the line. And position counting resets after the 9th space. Small diamonds are placed between the 9th and 10th positions along the line. So we know this is 1 through 9 here along this line. This has to be the 10th position, with arrows pointing in the new position 1. So this is the new position 1 and position 2. So instead of basically counting all the way up to like 11 here, it goes 1, 2, 3. The positions for these are 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it goes 1, 2 here. This would be, for example, actually let's look at the longest one. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it would be 1, 2, 3, 4, 5 here. Position, okay, so yeah, that's position counting resets. For example, if a line is 14 cells long, so this is 14 cells long, so this is the only example of it, I believe. This is 13, and this is 11. If a line is 14 cells long and it contains a 3 in the 7th position, so this would be 3, then a 7 must appear either in the 3rd position or the 12th position. So you could have a 7 here or here. Okay, so basically, interesting. No digit may act as indexer for more than one position. So if that same line had a 2 in positions 1 and 10, both of which are indexed by 1, position a 2 in 1 and 10, then you would need a 1 in positions 2 and 11. Oh, wait. Yeah. Sorry. This is 2 and this is 2. Sorry, this is 1. So if you had 2 in the 1st and the 10th positions, both of which are indexed by 1, you would need a 1 in positions 2 and 11, because that says, hey, there's a 2 in the first spot in one area, and there's a 2 in the first spot in this other area. So these appendix lines are essentially, okay, they're supposedly index lines, but with essentially repeats potentially, right? Let's see, how else can we explain it? So you have to index some part of, because the thing is, right, how do we describe it? They will essentially index each other, right? So for example, here, when you had you had a 2 in the first position and the 10th position, which are essentially the first position in each. They index that there is, first of all, they say that there's a 1 in one of the second positions. And the 1 itself in the second position indexes these 2s. which says there has to be a 2 in one of the first positions, right? So it can only index one specific digit, right? So if you only had a 2 here in, like, say, the first one, then only one of these has to be a 1, right? Because only one can index the first one. But either one of these could, right? So that's how appendix lines work. I hope those examples were were clear. Um, Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so first things first, probably the best thing then would be to basically say, where are the quads, essentially? So 2 and 9 have to be in these cells. So that means the 9 would then say that either the first, the second, the third, or the fourth digit since the 9 is in either the first, the second, third, or fourth position, the ninth position has to contain a 1, 2, 3, or 4. So this is specifically 1, 2, 3, or 4. This is also saying a 2 for the 2 position. It's 1, 2, 3, or 4. But it could be either this 2 or this 2. We're not sure which. We also know there's a 6 in one of these 3 positions. So for the 6th position, that means, so 1, 2, 3, 4, 5, 6. For the 6th position, you can have either a 9, an 8, a 1, or 2. So this is 8, 1, or 2 here to correspond to one of these digits, right? Because this is essentially the first position again. This is the second position. This is the 8th position. Okay. So 2 and 9 cannot be any of these. Okay. We have the digits 1 through 9 in all of these. Okay. What are the positions? The positions here are 1, 2, and 3. Okay. Uh, 9 cannot be here. And cannot be here. That means the 9 has to be one of these 6 cells. And since it's one of these 6 cells, that means it could be 1, 2, 3. It could be appendix 1, 2, 3, no 4, no 5, or 6, 7, 8. So this is specifically 1, 2, 3, 6, 7, or 8 for the 9. There's no 5 here. So the 5 in column 1 has to be in position 6, 7, or 8, and 1, 2, 3 also. And this is 1, 2, 3, 4, 5. So this is the 5th position, which is 1, 2, 3, 6, 7, or 8. Because there's only one 5 in this set. So that means the 5 has to again be one of these 6. Where can the 5 be in the rest of column 2? It could be any of these three. It could be here. It cannot be any of these. Hmm. Hmm. This is the first in a set. This is also the first in a set. Hmm. I actually haven't done very much with index lines either, so I'm not very familiar with what they imply. Hmm. One thing we do know is in this box 1, there's no 2 or 9 on this index line. So one of these digits has to be essentially outside of 1, 2, 3, 4. What does that tell us? I'm not really sure. Do the digits 1 through 9 have to appear in the complete set of 1 through 9? I don't believe so. Not for appendix lines. Hmm. 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 Right. Hmm. So what happens if, say, these digits are certain, like, well, hmm. Don't there need to be two, there needs to be 2 1s on this line and 2 2s on this line, right? Because whatever digit is here and whatever digit is here, they're both saying a 1 is in that position, and you can only index one of them, right? Each. So if this were both in, say, the second position, then they would have to both be 1. Oh, interesting. So if that's the case, hmm, I think that's, yeah. So that's the case for all the appendix lines, right? So then it has to be the digits 1 through 4 and then 1 through 9 again, right? Here. This is the digits 1 through 9 and then 1 and 2, right? Because whatever this is says that a 1 has to be in that position. Whatever this is says that a 1 has to be in that position. So there's 2 1s along this line. There's 2 2s along this line. And the rest are 3 through 9 or whatever, right? Hmm. So that means there cannot be another. Okay. Similarly, this has 2 2s also, right? Because there's a digit here that indexes where one of the 2s is. There's another digit here which indexes where one of the 2s are. So there must be 2 2s along this line. So this has to have the digits 1 through 4 twice. but 2 cannot be here. So 2 along this line, one of them has to be one of these 3, and one of them has to be one of these 6. Well, because of that, we know where the 2 cannot be. The 2 cannot be in this cell, these cells, or these cells. So it must be one of these, must be a 2. So if this is a 2, that's saying there's a 1 in one of the second spaces, or the 2 has to have a fourth space, right? Okay. This then has to be 1 through 5 and 1 through 9 once. Okay, so then we have, how many ones does that mean? We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 ones accounted for in these spots, right? So 1 cannot appear in any of the rest of rows 2 and 3 outside of this appendix line, because we know we need 2 1s represented in somewhere on this appendix line, and we need 2 2s. So the rest of these are 3, 4, 5, 6, 7, 8, and 9. Same here. This is 3 through 9. Hmm. What about this? I don't think it tells us much. Right, so this is 1 through 4 twice, so the rest of the column cannot contain 1 through, the columns 1 and 2 cannot contain 1 through 4. Because we have 1 through 4 twice, and then 5 through 9 once. So these are 5 through 9. These can't be 9. This is 5 through 9, and we have 5 through 9, but this can't be 5. This can't be, this is, yeah. So this is specifically, so 5 has to be here or one of these 2. Right, so this cannot be 6, 7, or 8. This can't be 6, 7, or 8 either. Okay, and because we have a 5, 6, 7, 8, and 9 quintuplet already in column 2. So this has to be 1 through 4. This is 1 through 4, but no 2. Okay, so that means for the 9th position, they have to be in the 1st, 2nd, or 3rd position for the 9. And this can't be 9, so one of these must be a 9. So one of these is a 9, which means this cannot be 9. This is also saying 5 must be in either the 1st, 2nd, or 3rd position on one of these sets, and it cannot be here because this has a 5. So this 1, 2, or 3 references one of these. So one of these is a 5, which means this cannot be 5. Well, now we have a 6, 7, 8, 9 quadruplet in column 2, which eliminates 6, 7, 8, and 9 the rest of the column. Therefore, this is a 5. The rest of these are 3 through 9. Well, we don't quite have enough. This cannot be 9. Also, we know one of these 2 is a 9. Therefore, this can only be 2 or 3 here. So this is not 1 or 4. It's 2 or 3 here. Okay. Well, therefore, one of these is a 5 here. Uh, um, if this is 4, it indexes itself, so that's fine. If this is 4, it indexes itself, so that's fine. We just don't know where the last one is. Hmm. Um, hmm. Hmm. So one of the twos is either in the ninth position, the fifth position, or the fourth position. If it's 9, that's 2. That's fine. Therefore, this would be 9. If it's the fifth position, this is 2, and that's 5, and that's fine. If it's here, this is 2, so 4 would have to be in here also, but then 4 would be in the second position. So it could not be here. It would have to be here if that's 4. There's also a 2 in the first, second, third. If it's the second, obviously chooses itself and indexes itself. If it's the first, then the 1 would have to be in here. If it's in the third position, this could be 3, right? So if 2's here, this could be 3. If it's in the sixth position, that means 6 could be here or here. If it's in the seventh position, 7 could be here or here. If it's in the eighth position, it could be here or here. Huh. Interesting. I'm not really sure what that means. Okay, these cannot be 6 here. I don't know what that tells us. There has to be a 6 in one of these, right? Which would be the eighth or 1 or 2. Hmm. Remaining digits. Okay, do we have any other information? Not really. So yeah, it's all down to essentially the appendix lines and trying to understand them. Hmm. The 3 has to be either in. Okay, one of these is a 6. So 6 cannot appear anywhere else on this line, right? Otherwise, you'd have two sixes indexing in to 1/6 place, and that's not allowed. So this cannot be 6 here, which means one of these two is a 6 here. Hmm. So one of these 5 is a 2. And that would be 5 through 9. One of these 4 is a 2. That would be 1 through 4. So 3 has to be 7, 8, or 9. Right? So this is indexing the third position, which means the third digit, 3 digit, must be in either the 7th, the 8th, or ninth position. So one of these is 3. And we know, so this cannot be 3 here. This can't be 3 here. And we also know that 7, 8, or 9 is indexing the is in the second position. So therefore the 2 also has to be one of these 3. So 2 also has to be one of these 3, which means there cannot be a 2 in the rest of the row. So 8 specifically, or sorry, 6 specifically has to be one of these 2 cells, right? If this is 8, that would force this to be 6. Therefore, 7 and 9 would be 2 or 3. That's fine. Okay. So this cannot be 2 here. Because this 7, 8, and 9 says there has to be a 2 in the 7th, 8th, or ninth appendix for this line, but there's only 1 for any of those. So therefore, one of these is 2, which means this cannot be 2. Therefore, this is a 2. So that's saying there's a 1 in one of the second positions. Well, it's not that one, so it must be this one. So this is a 1 here. So this is 1, this is 2. So this 2 is the index of a 1, and this is the other index of a 1, but we don't know which one. Well, it could be 6. It could be 4, 5, 6, 7. So this is 4, 5, 6, or 7 here. It cannot be 8, because that would be here, and that's not allowed. One cannot appear now in 1, 2, can't be in the 1, can't be third. 4, 5, 6 is fine. 7 and 9 are removed, so this cannot be 7 or 9. Because then the 1 would have to appear here, and that would break that. So it could be in the 4th. So 1 could be here, the 5th, 6th, 7th, 8th. So one of these 3 corresponds to this index. And we're not sure which. So one of these is a 1. I'm not sure which. Hmm. Hmm. So there cannot be a 6 in any of these. This can't be 9. 9 also has to be one of these 3. Hmm. Hmm. If this is 6 here, that means 1 is in the 6th spot. So it'd be 1, 2, 3, 4, 5, 6. So 1 would be here. 6 would be here. So this would be 6 and this would be 1. Neither of these could be 1, so it would be a 2, 3 pair, which means 9 would be one of these two. 5 would be one of these two. That seems fine. And this would be 1 or 4, and this would be 1 or 4. So the last digit here would then be a 4. Um, okay. So this is, well, okay. This is saying that there's a 1 in the 4th, 5th, 6th, 7th, or 8th positions. The 4th could be either one of these. The 5th is this one. This is 6, this is 7, this is 8. Either way, they all see this cell, and this one cannot be 1, right? So this, if the 4th is one of these, and they both see this cell. The 5th, 6th, 7th, the 8th ones are all these 4, and they all see this cell. So this cannot be 1. Therefore, 9 cannot be in the first position. It has to be either in the second or the third. We're not sure which. Um, this is 1, 3, 4, 5, 6, 7. That's fine. Hmm. We also have 8 2s on the lines, right? Right. Because, so we have 11 here, 11th length index line. We have 13, 13, and 14. So we know 2 has to be here or here. So the other remaining 2 is here, one of these 6 digits. This accounts for 2 2s. And actually, we know the 2 has to be here. Because we only account for 1 2 along this line. We have 2 more 2s along this line. We have, if we had a 2 here, well, okay, this one, no matter what, has to have a 2, right? because otherwise there's no other place for it. Because we have already this accounting for 1, 2 here. This is another. The other one is one of these 6 because none of these could be a 2. This accounts for 2 2s. This counts for 2 2s. So that's 4 amongst these 2 lines. And this one has to be one of them. And so okay, so these lines contain 8 1s, 8 2s, 7 3s, and 7 4s, and then 4 5s. Right? Because none of them are greater than, oh wait, there is one that's 14. So 5 5s. So we know there's a 2 in one of these 7 cells. There's a 2 either one of these 5 or one of these 5. Sorry, 6. And then there's another 2 in one of these. There's a 2 in one of these 4, 2 in one of these 5. So again, we have these index cells contain 8 1s, 8 1s, 8 2s, 7 3s and 4s, and 5 5s, and then 4 out of each of the remaining digits, 6 through 9. Okay, where is the 9 in row 3? We know one of these 2 is a 9. That eliminates 9 from the rest of the line. And this can't be 9, because again, that would force a 1 here. So 9 can only be in this spot. So this is a 9, which means this can't be 9. This is 7 or 8. So this has to be a 3, which means this cannot be 3. Right, because it's saying in the 9th spot there has to be the P digit, which is the positioning, which is 3. So that's 3. So this is the only place for 9 here. This is 3. Okay, so none of these could be 3. This can't be 3. Only one of these digits can be a 3. Therefore, this has to be, one of these has to be a 3 here. Okay, so 3 can be in the 4th position, the 5th position, or the 6th position. And then, so then we have a 3 in one of these positions, right? This is the 3rd position, which is fine by itself. So 3, 4, 5, 6, 7, 9. 3, 4, 5, 6, 7, 9. This is the 1st, 2nd, 3rd. So 3, 4, 5, 6, 7, 9. So no 8th position. So these the digits in the 3rd spot in the appendixes can only be 3, 4, 5, 6, 7, or 9 in 2. So 2, 3, 4, 5, 6, 7, 9. Okay. So one of these is a 3. One of these is a 3. So one of these is a 3. This cannot be a 3. So there also has to be a 3 in one of these cells. Okay, well that doesn't tell us very much either. So right now, yeah. Hmm. So this has 1, 3. 3 cannot be here. 3 has to be one of these cells. So that counts for a second 3, or 1, 3 that's off the lines. And remember, we count for 7 threes on the lines. This is already 1 off, and these 4 boxes contain a 3 because they have the digits 1 through 4 at least twice each, or exactly twice each. This one also has 1 through 5 in its subset. Um, this could be a 5, though. Hmm. 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 No, no, never mind. Hmm. This cannot be 3 here. Which means there's 2 3s along this line, but that allows one valid 3 somewhere not along this line, right? This could be any of them. Okay, if this is 7, the problem with this being 7 is that eliminates 7 here and all along this this appendix line. And there's no 7 then possible in row 3 if that's the case. So this cannot be 7. This has to be 8, which means none of these can be 8. Therefore, that's saying in the 8th position there's a 2. So this has to be a 2, which means this can't be 2. This can no longer be 8 because we already have the only index on it equating here. So this must be a 1. So this can't be 8. There can't be 8 along the rest of the appendix line. So this must be an 8 because that's the only place 8 can be in the row. Yeah. Which means in the 8th position, there's a 1. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So 8 has to be here. So 1 has to be here. Sorry. There needs to be another 1. And it cannot be any of these, can't be any of these, can't be here, can't be any of these. The last one has to be here. So this is 1. So this 1 says that in one of the first positions, you need an index of 4, right? 1, 2, 3, 4. Well, we already have this one as an 8, so this must be a 4 then, which means this cannot be 4. This can't be 4. In column 2, we now have a 1, 2, 3 triplet, which eliminates 1, 2, and 3 in the rest of the column. Therefore, this is a 4 here, which means this cannot be 4. If this is, okay, so if this were 3, the problem is that would mean that a 4 has to be in a third position somewhere. Well, it can't be here because of this 4, and it can't be here because of this 4, so this can never be 3 then. The rest of this is 4, 5, 6, 7. But this can't be 4, so one of these two is a 4. So 4, there's no 6 possible anymore in this. So this can't be 6, this can't be 6. This has to be a 6 because of the indexing of the 1. So this is a 4, 5, 7 triplet now in row 3, which eliminates 4, 5, and 7. And the reason why is we have a 6 already here, and none of these could be 6 then. Well, where's the 6 in row 3? It has to be here. So this is 6, which means this can't be 6. We have now a 1 in position 6. And the only position 6 is here, right? 1, 2, 3, 4, 5, 6. So this is a 1, which means this can't be 1. This is a 2, 3 pair, which means we eliminate 2 and 3 from the rest of the column. This can't be 2, so this is a 1. That's indexing on a 4. So the 1 is in the 4th position, which says that a 4 has to be in one of the 1 positions. This can't be 4, so this must be a 4 here. This can no longer be 1 because of one of these ones. Therefore, we have a 3, 5, 7 triplet in box 1, which eliminates 3, 5, and 7 in the rest of the box. Also, we know 5 has to be here. This can't be 5, so this is 7 because of this 5. So this becomes a 3, 5 pair here, which eliminates 3 and 5 in the rest of the box and the rest of the column. So this has to be a 1. These can't be 8. This can't be 8. This can't be 7 here. This 7 says that the 4 has to be in the 7th spot. So therefore, this is 4, which makes this 5. These can't be 4, 5. This can't be 6. So we have a 3, 7, 9 triplet now in row 2, which eliminates 3, 7, and 9 the rest of the row. This can't be 3, 7, or 9, so that makes that 5. This can't be 5, 7, or 9, so this must be 4 now. This can't be 2, and this can't be 2 here. This has to be a 3. So we have a 3 in the 3rd position already. So that's fine. We also have a 5 in the 2nd position, which means there has to be a 2 in the 5th position. So this must be 2, which makes this a 3. The last 3, so the 3 is in the 9th position, which means there's a 9 in the 3rd position. So this is 9. This can't be 9. None of these digits can be 2, therefore this must be a 2 here. These can't be 8 anymore, so we have 6 and 7 here. The remaining digits here are 3, 5, and 8, and this can't be 5 here. Remaining digits here are 7 and 8, so this is 7 or 8, and they could be swapped. We don't know which. Remaining digits here are 4, 6, and 9. Not 7, 4, 6, and 9. This can no longer be 3. None of these can be 2. That doesn't tell us very much. We have an 8 in the 1st position. 4 is in the 1st position. So one of these is a 2, because one of these 4 has to be a 2. Right? And only one of these 4 can be a 3. Sorry. One of these 4 is a 3. One of these 2 is a 3. Because one of these 4, only one of these 4 can be a 3. And this can't be 3, these can't be 3s. So therefore one of these is a 3, which means this cannot be 3. So 3 has to be either here or here. 4 cannot be... Where can 4 be on this line? It has to be there twice. Well, it can't be here. Can't be any of these. can't be any of these, can't be here, so it must be one of these two, and it must be one of these two. So this is a 4, and this is a 4. The remaining digits here are, what, 2, 6, and 8, and the remaining digits here are 5, 7, 9. Four cannot be any of these cells. So 4 again is one of these two, and then one of these two. If 4 is here, okay, so in this position, okay, let's see how many digits. Okay, there's no more 8s along this line because we already have an 8 indexing, and there's only one 8 index to index. So this can't be 8. These can't be 8. This must be an 8 then. Therefore, 8 must be one of these two cells, and this can't be 8 because, again, we have only one 8th position to index, so this can't be 8, which means the only possibility then for 8 has to be here. So this is an 8, and this is in the 1, 2, 3, 4, 5th spot. So in the 8th spot, 1, 2, 3, 4, 5, 6, 7, 8, there has to be a 5. So this is 5. And then we have something here, which says where 5 can be. Okay, so this can't be 5 anymore because of that. This can't be 5. Well, now we know where the 5 is in box 7. It has to be here. So then 5 has to be one of these two spots. So 1 has to be one of these. 1 has to be... okay, so for this line, we have two 1s along it. It has to be one of these two. And it cannot be either any of these. It can't be here. It cannot be this one. So it has to be here. So this is a 1, which means this can't be 1. So this is therefore a 1. That's in the first spot already, so that's indexing itself. This is a 1 that's in the 3rd spot, so we need a 3, and therefore this is the only place for 3. So this is a 3, which means this can't be 3. So one of these two is a 3. So there has to be a 2 in one of the 3rd spots. Well, it can't be here. It can't be here. No, sorry. If this were 3, it would have to have a 3 in one of the two. It would have to have a 2 in one of the 3rd spots. But this can't be 2 and this can't be 2, and those are the only 3rd spots along this appendix line. So this cannot be 3, which means this has to be a 3 as the only remaining space left. So this is 3, which is indexing itself. The other 3 has to be one of these two cells. So this is what? 5 and 6. So this has to be a 5 or 6 to index it. 2 cannot be here or here. Remaining digits along column 8 are 2, 5, 7, 9. And this can't be 2 or 5, and this can't be 5. The remaining digits along column 7 are 4, 5, 6, 7, 9. And this can't be 4 or 9. So 4 has to be one of these two cells. And it is 7 or 9 indexing it, right? We have a 1 in the 4, that's already there. So one of these is 4. One of these two has to be a 4 in box 6 for rows 5 and 6. There's another 4 in also rows 5 and 6, which eliminates 4s in the rest of rows 5 and 6. So these cannot be 4. We now have a 6 and 9, 6 and 9 pair in column 3, which eliminates 6 and 9 in the rest of the column. That makes this a 4. If this is a 5, that means that there's a 2 in the 5th position, which would only be here. Or this is a 5, which means there's a 2 in the 5th position. So if this is 5, that says there's a 2 in the 5th position along this row, or along this line. So this would then be a 2. If this is a 5, that's saying there has to be a 5. There has to be a 2 in the 5th position in one of these. And it cannot be here because this is an 8. It would have to also then be here. So this would be 2 or 2. So one of these is a 2 here. Which means one of these is a 2 here. And we know one of these 3 is a 2 here. We're not sure which. Okay. Remaining digits in column 9 are 2, 5, 6, 7, 9. So this could be 2, 5, 6, 7, 9. This cannot be 2 or 5, so it's 6, 7, or 9. This could be 2, 5, 6, 7, no 9. And this could be 2, 5, 6, 7, 9, no 5 though. The remaining digits in row 9. Actually, okay, this can't be 3 anymore. This can't be 3 because of this 3, so this is 8, which makes that a 3. Therefore, this can't be a 3 either. So one of these 2 is a 3. Okay, so one of these 2 cells is a 3. The remaining digits in row 8 are 4, 6, 7, 9. The remaining digits in row 9 are 2, 3, 6, 7, or 9. So, 4 is either in the 4th slot or the 5th slot. Let's see. 9 has to be one of these 4 cells in box 8, which means there's a 9 on this line, which means we can remove 9 from the rest of this line. So this can't be 9. This is 2 or 7. Which we already knew, actually. This couldn't be 9 anyways, because that would force a 4 to be there, which is not allowed. So this is 2 or 7, which matches these. 3 is one of these 2. And therefore, if 3 was here, that would be the 9th cell. So a 9 would have to be in one of the 3rd cells, and it can't be here, so it would have to be here, but that's not allowed. So 3 cannot be here. Therefore, this is a 3. And since this is 3, it's saying that this is 1, 2, 3, 4, 5, 6. In the 6th, we are in the 6th position. So a 6 has to be in the 3rd position, therefore this is a 6. We know there has to be a 2 in one of these 2. There has to be a 2 in one of these lines, so this must be 2. This can't be 2, which makes this a 7. So that's saying that we have a 7 in the 4th position, which means we have a 4 in the 7th position, and the only 4 would be, then this is 9. So this 7 says first of all, it means this can't be 7, so this is 6, which makes that 7. This can't be 2, 6, or 7, so this has to be 9. Oh, we have a problem here. Okay, yeah, we don't know anything about this 2. We do know about the 3, though. This 3, if this were here, this would force this to be a 9, which is not allowed. The 2 actually could be here. This is not a 2. We have to have a 2. We have to have 2 2s along this line and 2 2s along this line. Doesn't this have to be a 2 then? Or is this a 2? Yeah, this has to be a 2. So this is 2, which makes this 7. Which makes this 6, which makes that 7. This 7 says there has to be a 4. Hold up. Okay. One of these... Huh. That's a little problematic. So that implies this has to be 2 and this is 2, right? Which means none of these can be 2, which means this has to be 2, but then this would be 3. So this would have to be 9, but that's not allowed. Huh. I must have messed up somewhere earlier. Oh man, that's gonna be a pain though to try to figure out. Okay, let's again. So we've figured out sort of how the appendix lines work, right? There have to be enough indexes to match how many index positions there are. So therefore, 1 and 2 are doubled along this line to index those positions. 1, 2, 3, 4 are doubled along these line and this line. And then 1 through 5 is doubled along these lines, right? We know the 9 has to be one of these cells. This has to be... This is already the digits 1 through 9, so these have to be indexed 1 through 4. Right? This cannot be 2. We know there's a 9 here, so there cannot be a 9 in the rest of this row. If this were a 9... Oh, it can't be 9. So none of these can be 9. This can't be 9 along the rest of this row. This could be a 9. I don't know how I eliminated a 9 from there. Oh, maybe it was just that this had to be 9, right? Well, the rest of this is 5 through 9. This is 5 through 9, and this is 5 through 9, but it can't be 5. Or it could be 5 here. The 9 cannot be any of these cells. So one of these is a 9, which is saying that, again, in the 9th position, we have 1 through 4. That's fine. 6 has to be one of these 3, which means there cannot be a 6 in the rest of the row. This is saying there has to be a 2 in the 5th, 7th, 8th, or 9th position. Right, so we also know this is 3 through 9 here. These are 3 through 9 because they cannot contain, and neither of these can be 9 because there's a 9 in around one of these 4 cells. So 2 has to be one of these 2 cells here, which means none of these could be 2, which means 2 could be here, 2 could be here. 5 could be here. Oh, was this 5 maybe the error? Maybe. Yeah, I think this might have been the error here. Is removing 5 from this possibility. Okay. People probably were basically yelling at me for like, why did you remove 5 from here? Because it has to be one of these 4 cells, right? Okay. Well, there you go. That's probably where I messed up. Okay. But the logic all still fits, right? So one of these has to be 9 here, which means 9 cannot be anywhere else on here. This is the 5th position with 1, 2, 3, or 4. 5 cannot be any of these 4, so 5 can only be one of these 3. So this has one of these 3 has to be 5, which means this can't be 4. 9 is in a similar position. 9 has to be 1 through 4, so it's one of those 4 and one of those 4, but it can't be any of these because a 9 has to be one of these. It can't be here, so 9 also has to be 1 through 3. So 9 is one of these 3 positions, which means this can't be 9. Yeah, so this was the problem, was this, yeah, okay. We have a 2 somewhere along in the 5th, so the 2 can either be here, 5th, 7th, 8th, or 9th positions, which means 2 cannot be in the rest of that row, so this cannot be 2, which means this has to be a 2. So, okay, there, that logic is still the same. This 2 says is in the first position, which says that then a 1 has to be in the second position. Well, this can't be 1 in the second position, therefore this must be a 1 in the second position here. Therefore this can't be 1. The 9 could be 2, 3, or 4. That's fine. If this were 9 again, yeah, where is the 1 possible to be? It could be in the second position, but it can't be because this 2 is ruled out. Also, we know a 3 has to be in the 5th, 7th, 8th, and 9th positions also. So one of these is a 3, which means none of these, the rest of the row could contain a 3. So this can't be 3, this can't be 3. These can't be 6 again, because one of these 3 digits is a 6, and really one of these 2. The rest of the line cannot contain 6. So this is saying that a 1 has to be in the 4th, the 5th, the 7th, 8th, and 9th positions. But it cannot be 7, 9 because those are the only 2. It could be 4 here. That's fine. But in the 7th or 9th positions, we have a problem, right? It would have to be in one of these 2 spots then. But that's not allowed. So this cannot be 7 or 9. Well, where is the 9 now? This could be 4. Huh. Maybe that's another one that I messed up. Anyways, okay, so 9 has to be one of... Yeah, okay, well, I didn't know that was not a 9, so that was one issue. So the 9 in row 3 must be one of these 2 cells. Because otherwise, yeah, so because it was all because I put a 5 not being here. So 5 has to be here, which means this can't be 5. That's fine. So therefore, this can't be 2 or 3 here. One of these three is 2 or 3. 9 in on row 3 can't be in the rest of the line because we know one of these three is a 9, and you can only have one 9 indexing the 9th spot. So it must be one of these three. And specifically, it has to be one of these two because this can no longer be a 9. So this can't be a 9 here. So that's saying 2 is in either the 7th or the 8th position. So this cannot be a 2 anymore. Cannot be a 2. Can't be a 2. Okay. Um. Huh. So 2 has to be one of these two. 2 is also one of those 6. Again, we need a 2 along this line. We need that. There's a 2 here somewhere. And we can have a 2 in either here or here. Okay. So yeah, my error was in the very beginning, which is not good, but there's no 5 here. So there's a 5 either here or here. But this cannot be 5. Well, actually that could be because that could be 1. Oh. Well, okay. So there's no 5 here because one of these is a 5. Therefore, there must be a 5 either here or here along this line. And therefore, this can't be a 5. So this is 4 or 8. So along this, we know there's a 1 along here, and then a 1 in these two lines, right? There's actually, so there's a 1, there's all the 1s, 2s, all the 1, 2, 3s, and 4s have to be along these lines. Because you don't have any available there. Right? There's 2 of 1 through 4 each in these lines. But this could be 4. But 1, 2, and 3 then have to be only along the lines. So where are the 1s? 1s cannot be here. 1 has to be one of these 4. And then the other 1 has to be one of these 3. Therefore, 1 cannot be here. 1 could be any of these 4 along the lines. And it cannot be here because one of these has to be a 1. So this is a 1 along this, and then we need another 1 in here. So one of these is a 1. This 1 cannot be in the 4 position. It could be 5, 6, 7, or 8. So this is 5, 6, 7, 8. No, not 8. 5, 6, or 7. So 1 has to be one of these 3 cells because it cannot be any of these. I guess it could be 4. So 4 is also possible. This is 4, 5, 6, 7. So 1, there's a 4 or an 8 here. So that would mean this is 1, this is 1, or this is 1. So if it's 4, either this is 1 or this is 1. If it's 8, this is 1. Which means this can never be 1 here. Okay. Hmm. Um, hmm. This could be one. Be one. Cannot be 2 or 3. It could be 4 through 9. Hmm. What digit can this be? Again, it cannot be any of these ones. It could be 4, 5, 6, or 8. Or 1 or 4. So this could be 1, 4, 5, 6, 8 as possibilities. Um, hmm. So whatever this digit is has to match here, right? Because we see all these digits. This digit is also, so all of these digits are the same no matter what. This digit sees that one, so obviously it can't be here. And this is a 4, 5, 6, or 7. Oh. And then this digit, okay, so this digit, whatever this digit is, it sees all of these. And one of them has to be a 4. So this cannot be 4. This has to be an 8. Right? Because otherwise, it sees all of these digits, which has to have a 4 somewhere. And so one of these is 4, which means this has to be an 8. Which means the 8th digit has to be a 1. So there we go. We have that again. So this is 1, which means this can't be 1. None of these could be 1. So one of these 2 is a 1. The only remaining 1 now on this line is here. So this is 1, which is saying that a 4 has to be in the first position somewhere. Can't be here, so they must be here. So this is a 4, which means this can't be 4. And then we have a 1, 2, 3 triplet, which eliminates 1, 2, and 3 from the rest of the column. So this must be a 4, which means none of these could be 4. This can't be 4. And none of these could be 8. We also know none of these can be 8. We still need an 8 on the line, so it has to be here. So this is an 8, which means this can't be 8, this can't be 8. And this can't be 8. This is a 4, saying 4 is in the 4th position, which it is already, so that satisfies itself. These can't be 4, this must be a 3. And this can't be a 4. So 1 cannot be in the 4th position. 3 is in the 9th position, so therefore this must be a 9, which means this can't be 9. 1 has to be in the 2nd or 3rd position here. But we don't know which one's which. This can't be 1 anymore. So 9 cannot be in the 1st position, so it cannot be here. The remaining digits here. One of these is a 6, so this can never be 6. Therefore, 4 is either in the 5th or the 7th position. So this is either 4 or this is 4. Whatever digit is here has to be the same as that digit. Okay, the remaining digits are 1, 2, 4, 5, 6, 7. And again, so this can't be 1. This can't be 1. So now 1 is only in the 5th or the 6th position. So this can't be 7. This is 5 or 6, which means this is 5 or 6, because again, this matches this cell. because it cannot be a repeat of 1 or 2. Again, these can't be 2 then. Oh, 2 is in the 8th position. So this must be a 2 then. So this is a 2, which means this can't be 2. This cannot be 3 or 8. There's no more 8s along this line. Therefore, 8 cannot be here. 8 can't be on the line. It must be here. So this is 8. Well, where's the 8? Again, 8 can't be on the line anymore, so this must be an 8. This is 1, 2, 3, 4, 5. That's saying in the 8th position there has to be a 5. So 1, 2, 3, 4, 5, 6, 7, 8. This is a 5 then, which means this can't be 5, so one of these two is a 5. We still have a 5 here or a 5 here. Yeah, it was all on this. I don't know why I removed 5 here. Yeah, that was a mistake. Anyways, if there's a 5 here, that means there's a 2 in the 5th position along this line, which would only be here. So this would be 2. If there's a 5 here, that's saying there's a 5 along in the 2nd position. Sorry, there's a 2 in the 5th position along here, but this 5 is already taken. This 5th position is taken, so it has to be here. So one of these is a 2. There has to be a 2. Well, I guess either of these could be a 2, so that still works. So either of these could be a 2. One of these 3, I guess it could be one of these 4. Could be a 2 also. Okay. So one of these is a 2. Interesting. Okay, let's look at the remaining digits. This has to be 1, 3, 5, 6, or 7. This is 1, 3, 5, 6, or 7. This cannot be 1. One of these is a 1, so 2 or 3 has to be in one of the 1 positions, so that's fine. Again, 3 can only be once in one of these 5 positions. So that means 3 actually has to be also one of these 2, right? We also need a 4. 4 can't be here. 4 could be any of these. Hmm. 8 cannot... Okay, so we also have an 8 here. 8 cannot be on this line, and it cannot be on this line. And 8 can't be here. 8 can't be here. 8 can't be on this line, so one of these 2 is an 8. And these can't be 5. This is saying that a 7 is in 1, 2, 3, 4, 5, 6, 7. Right, a 7 is in the 4th, the 6th, or the 7th position. So this can't be 7 here. This can't be 4. These can't be 4 because one of these 2 has to be a 4 because of 5, 7. Let's see. 8 has to be one of these 2, which means 8 is one of these 2 here. 8 cannot be on this line because we already have the 8 indexed for this appendix cell. So one of these 2 is an 8, which means this can't be 8, so one of these 2 is an 8. So the 8 can only be in the 1, 2, 3, 4, 5, 6, 7th cell or the second cell. So this is 2 or 7 here. Okay. This cannot be 9 because of a 9 here. So 9 has to be one of these 3. We're not sure which. So we have all the 1s here. One of these is a 1. This cannot be 1. So 1... So this digit could be 1, 2, 3. This is 1, 2, 3 also. So 2 or 3, 1, 2 or 3, or 7 or 9. So this is specifically 1, 2, 3, 7, 9. Same here. This is also only 1, 2, 3, 7, or 9, but it can't be 1. So 2, 3, 7, or 9 to match these 1s possibility. The 2s can only be 1, 2, 3. I guess a 5, but that's if one of these is a 5. Can this be 2? If this were 2, that would mean that it would have to be a 4 in one of the second spots. But this is a second spot, and that's the second spot, and they both see this 4. So this cannot be 2 here. Therefore, in box 9, we know the 2 has to be along this line. And we know it has to be here, so it cannot be here. Right? So there has to be a 2 along this line, because none of these can be 2. And where is a 2 in this box? It has to be along the line, because we have 4 2s accounted for on the lines, and those are the 4 in these 4 boxes in the lower right. So this has to be a 2, and this has to be a 2, which means there cannot be another 2 on the line. So this can't be 2. This cannot be 2. So therefore, where's a 2 in box 6? It has to be here. Where's a 2 in box 5? It has to be here. Therefore, this 2 is in saying that a 2 has to be in the second position, which it's already satisfying. And this 2 is saying that it has to be a 2, has to be a 5 in the second position, so it has to be here. So this is 5, which means this cannot be 5. This can't be 2 anymore. So one of these is 2 or 3. This can't be 2, so therefore this must be specifically 3 and 7. This 7 says the 8 has to be in the 7th position, so this is 8, which means this can't be 8. This 3 says the 9 has to be in the 3rd position, which means it has to be here. So this can't be 9 or 8 anymore. This is an 8. This cannot be 8. This can't be 7 here, so one of these 2 is 7. This is a 3, which means neither of these are 3. This has to be a 1-2 pair, because where else can they be, right? These can no longer be 1 and 2. The 1 and 2 in this box has to be on the line, so one of these is 1 or 2. We now have a 1-2, 1-2 pair in row 7, which eliminates 1 and 2 in the rest of the row. This can't be 1 or 2 specifically. Actually, these can't be 2, period, because of this 2. So either this is a 2, in which case it's indexing itself, or it's a 1, in which case it's saying a 2 has to be indexed there. That doesn't really tell us much, though. Anyways, let's continue. We need... Okay, so what are the remaining digits in column 8? They are 5, 6, 7, 9. This can't be 5, though, because of this 5. So this is 6, 7, 9. And this is 5, 6, 7, 9. So 5 has to be one of these 2 digits, which means there cannot be a 5 in the rest of the box. This is 4, 7, or 9. We know this has to be a 3 because one of these is a 3, but where's the other 3 in this line? It has to be here. So this is a 3. This can't be 3, this can't be 3, so one of these two is a 3. We also know this is the 6th position. 1, 2, 3, 4, 5, 6. So we need a 6 in the 3rd position. So one of these is a 6, but we're not sure which. Um, 4. Where is the 4 in column 7? Can't be here. Can't be either of these two cells. Can't be any of these. So it must be one of these. So that's saying that if this is 4, that's saying a 3 has to be in the 4th position. But this can't be 3. And this is already taken. So this cannot work as a 4. If the 4 is here, that's 1, 2, 3, 4, 5, 6. This is saying that in the 4th position, so this is already 1. In the 4th position, you could have a 7 or a 9. So this has to be 7 or 9 here. Remaining digits in column 7 are 3, 4, 6, 7, 9. Okay, let's just fill them out. 3, 4, 6, 7, 9. 3, 4, 6, 7, 9. But this can't be 4. This can't be 3 or 7. 3, 6, 7, 9 because it can't be 4. This can't be 3 though. This can't be 3. So if this is 3, this would have to be 9. Right? If this is 3, that's saying that the 9 has to be in the 3rd position. Well, actually, this could be 9. Or 3 is in the 3rd position here. So this is also 3, 6, 7, 9. Okay. Why do I have 6s here? I don't get it. I'm not sure. Okay, so I don't know why I have 6s in those positions. So the other 4 is in the 1st or 2nd position. So therefore 4 has to be one of these two. 5 is in the 1st or 2nd position, so this can't be a 5. This is saying a 1 is in 5 or 6. So this is 5 and this is 6. So one of these has to be a 1, which we kind of already knew, but... Hmm. Oh, this has to be a 6, because that's the only place left for a 6. So this has to be... that's why. So this can't be 6, right? And this can't be 6, and this can't be 6. So this is 5 then. That's the only remaining place for 5. So this can't be 5 here. We know one of these is 5 because it's either in the 1st and 2nd positions, and it can't be there because one of these has to be a 5. So this can't be a 5 anymore. This has to be a 7, which means none. This is saying the 4 has to be in the 7th position, so that's a 4. These can't be 6 at all. They couldn't be 6 anyways. So this can't be 4. This 6 means this has to be... None of these can be a 6, so this has to be a 6 here. So this is a 6, which is saying 6 is in... 1 is in the 6th position, so this is 1, which makes that 2, which makes that 1. This can't be 1 anymore, so that's 2, which makes that a 1. 1 cannot be either of these cells. So 1 can never be in the 7th position. So this we have a 7, 9, 7, 9 pair in box 9, which eliminates 7 and 9 in the rest of the box. Therefore, this is 3 or 6. This is 3 or 6. Well, we know along this line there's 2 3s. This can't be 3, so one of these must be 3. And we need another 3. It has to be here. So this is 3. Therefore, this can't be 3 anymore. And where's the 3? It has to be here. And this satisfies its own index, so that's fine. This 3 satisfies the 1 index, so that's fine. 1 can now be only 1 or 9 as an index, so this can't be 2, 3, or 7. So this is 1 or 9 for these. This 2 satisfies its own. This 2 could satisfy its own, or it could have a 6. So this is 2 or 6 here. The remaining digits here are, in row 7, have to be 3, 6, 7, 8. Not 9. 3, 6, 7, 8. And this can't be 8. This can't be 8. Again. This can't be 3. The 3 could index its... Okay, this can't be 3, so therefore this is 6. The 3 could index itself. It could be the 6th one, but it cannot be the 7th one, right? If this is 7, that would mean 3 has to be in the 7th index position, which is not. So this can't be 7. This is 3 or 6. This can't be 6. So we have a 3 in the 6th position. Therefore, this must be a 6 here. So these can't be 6. This is 4, 7, and 9, and we're not sure which is which. This cannot be a 6, a 1, or a 7. So therefore, this is a 3, and this is a 5. That's saying 5 is in the 2nd position. Or, sorry, 2 is in the 5th position, which it is. 3 is already in the 3rd position here. This is a 2-4 pair. The 1 has to be in the... 1 is here in the 4th position. It's saying 4 is in the 1st position. So this is 4. This is 2. This cannot be 2 anymore. Therefore, this makes this a 6, which makes that 7, which makes that 5. And that's a 6. And that's where we ran into the problems. So this can't be 5 anymore. This is now a 3, 6, 3, 6 pair, but this can't be 6 because of that 6, so this is 3, which makes that a 6. This 6 means this can't be 6, so this is 3. This can't be 3 or 6. This has to be 7 or 8 here. Where's the 2? This is saying a 2 has to be in the 6th position. 1, 2, 3, 4, 5, 6. So this is a 2. The remaining digits here are 1, 7, and 9. This can't be 7 because of this 7 here. So this must be a 9, which makes this a 7. This 9 says a 4 has to be in the 9th position. So this is 4. If this were not, this cannot be 4 anymore. And if it were 9, that would say a 7 would have to be, or a 9 would have to be, a 7 would have to be in the 9th position, which it can't. So this must be a 7, which makes this a 9. This can't be 9. This becomes a 4, 7 pair. None of these are 5. This can't be 7. We have a 6 in the 1st position, so that means that 1 must be in the 6th position, which is here. So this is 1, this is 5. This cannot be 1 anymore, which forces this to be a 1. That means this is a 9, because they have a 7, 8 pair. In the 7th position is 4, so therefore we have to have a 7 in the 4th position, which is 1, 2, 3, 4. Or actually, we already have it here, so this is 4. Interesting. So then this is a 4, 5, 9 triplet. Remaining digits in column 9 are what? This can't be 4. The remaining digits here are 5 and 9. and this is 4, 5, or 9. Cannot be 5 because of this 5. So it's 4 or 9, but you already have a 9, so this cannot be 9. We already have a 9 on the line, so it cannot be 9, so this is a 4, which means this can't be 4. We have a 5, 9, 5, 9 pair. We also know this has to be 1 because of the 3, 6, 7 already there. This has to be 4. This is 5, 8, and 9 here. Remaining digits here, well, we already have 1 through 9 once each. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Therefore, 6 through 9 cannot appear on this. We have 1, 2, 3, and 4 already duplicated on the line, so this has to be a 5. So this is a 5, which makes this a 9, which makes that a 5, which makes that 9, which makes that 5. And neither of these can be 5. So this is saying that a 5 has to be in the 4th position, and a 4 has to be in the 5th position, which it satisfies. This can't be 8 anymore. This can't be 6. We have a 3, 7, 9 triplet in row 2, which eliminates 3, 7, and 9 in the rest of the row. Therefore, this must be 4, which makes that a 7. The remaining digits are 2, 6, and 8. These can't be 2, so this must be a 2. We have 6 and 8 here. Okay, so this is 6 and 8. Neither of these can be 3, so therefore this is a 3 here. This can't be 9 in either of these spots, so therefore this is an 8 and 7 respectively. This 8 makes that a 9. This 7 makes this a 9. This 8 makes that a 6, which makes that an 8. Therefore this is a 7, that's an 8. And we should have the remaining digits. This has to be 7, and this is a 6. Wow, apologies for that. I don't know why I removed the 5 from here. That was really bad. Yeah, I'm not sure. Maybe it was because of the, I don't know, the 9, and then I accidentally removed the 5 instead. Who knows? Anyways, yeah, if you don't make that mistake in the very beginning of removing the 5s in these two cells, it should flow fairly well. Very interesting about this appendix lines. And just having, like, knowing that each index essentially has to be on the line as many times as it indexes is very important. So that's actually a good shortcut to know in the future for these types of puzzles. Anyways, I hope you enjoyed this solve. Hopefully you didn't make the same mistake I did, which is remove a 5 from here just randomly. And I'll see you next time on Frank Puzzles. Take care.